In this first example problem, what I have is a one-step equation, or a one-step inequality. X is being multiplied by -5. So I'm going to do the opposite. I'm going to divide by -5, right? This is multiplication, so I'm doing the opposite. So this cancels. I'm left with x. 15 divided by -5. Positive divided by negative is negative. 15 divided by 5 is 3. Now here's what I need to remember. Here, I just divided by a negative number. If I multiply or divide by a negative number, this sign flips around. So right now, it's pointed that way to the left, so I need to flip it around so it's pointed this way. So this would be my answer. And when I go to graph that, it would look like this. My graph here is at -3. When my graph is on the negative side, right? Imagine like this is 0 over here. This is -1, -2, -3, -4. Looks like this. This is an open circle. It's an open circle because this is greater than, right? It can't be equal to -3. It has to be greater than -3. And since x is greater than -3, I'm shading to the right. So my graph of this would look like this, right? Which means that my answer could be -2, it could be -1, it could be 0, it could be 100, it could be anything along this line. Let's take a look at this next one. This is a two-step equation, and it starts just the way you would solve just a regular two-step equation. We can kind of ignore that inequality sign for a little bit. So I'm trying to get x by itself. It's on the right side. I'm going to get rid of this 15 first. 7 minus 15. I have more negatives than positives. That's negative, subtracting. I get 8. In order to get x by itself, right now x is being multiplied by 4. I'm going to divide by 4. This is negative divided by positive is negative, and 8 divided by 4 is 2. I'm going to bring down my x. Now, notice here, I did not divide by a negative number. I did get a negative number as an answer, but that doesn't matter. I didn't divide by a negative number, and my sign does not flip around. Okay, my sign does not flip because I didn't multiply or divide by a negative number. So then this is what the graph looks like. Here's -2. Okay, again, on the negative side, the numbers kind of go backwards, right? This is 0, -1, -2, -3. In this case, I have a closed circle, x, and I'm going to do this, right? I'm going to flip this around. Since x is on the right, I'm going to go ahead and flip it around and put it on the left side. Okay, why? Because it just makes it way easier for me to think about what this means and graph it, because this says x is less than or equal to -2. So that's a closed circle because it could be -2, or it could be less than -2, so I'm going to shade to the left for less than. Okay, so this answer could be -2, it could be -3, it could be -100. Okay, but it's got to be somewhere to the left of this. And the last example, this one I have variables on both sides. I have some distributive property. Okay, so we're just going to use what we learned about equations. Notice it doesn't really matter that this is an inequality right now. Right now I'm simplifying on the right. This is positive times negative is -15. I have variables on both sides. I'm going to go ahead and knock the variables off the left side. Okay, now I could have chosen to subtract 10x as well. That would have been fine. And I would have ended up with negative coefficient next to x over here, which would have been fine. I'm going to choose this instead. Okay, I'm still looking to get x by itself. I'm going to add 15. And then I'm going to divide by 7. I end up with 2 is less than or equal to x. Since I have x on the right, I'm going to go ahead and switch it so x is on the left. Notice I switch everything around. The sign flipped, everything flipped. This way. Okay, everything flips around, so the sign is still open towards the x, right? Everything's pointed the other way. So this is x is greater than or equal to 2. And that looks like this. Here's 2. 1, 3, right? This is 0 over here. So here's 2. Could be equal to 2, or it could be greater than 2.